Let's look at the sign rules for factoring trinomials. First, you should always look at the last sign. If the last sign is positive, what kind of numbers could have multiplied to give you a positive? They could both be positive, or they could both be negative. So to multiply to get a positive, we have to have like signs. Now, we don't know which they are, so we have to look back then and take the sign of the middle term. So for this problem, we look at the last sign. It's a positive, so it says our signs are going to be alike, either plus plus or minus minus. We have to look back to the sign of the middle term to decide. For this situation, we're going to have both positive signs. Let's look at this trinomial. We would first go to the last sign, and it is positive, so it says our signs are going to be alike, either two positives or two negatives. We don't know which, so we have to go back and we will take the sign of the middle term. So we're going to have two negative signs in this setup. Let's look at this trinomial. This time our last sign of the trinomial is a negative. What kind of numbers multiply to give a negative? You have to have one of each. You're going to need a positive and a negative. The order doesn't matter until you put the numbers in. So it could be negative, positive. But to get a negative when you multiply, you must have one of each. So we can put these signs in. We don't have to look back to the middle term. For this trinomial, we will look at the last sign. Since the last sign is negative, we know that we will have one of each, a plus and a minus, and we can just put them in. The order doesn't matter until we fill in the numbers. We don't have to look back. Let's practice finding the signs for these trinomials. So first we will look at the last sign. On this one, our last sign is negative. That says our signs are going to be different. We need one of each. We don't have to look back. Problem 2, our last sign is negative. Our signs are going to be different. One of each. We don't have to look back. Third problem, our last sign is positive. That says our signs are going to be alike, either two positives or two negatives. We have to look back at the sign of the middle term to see what they'll be. So this one will have two positive signs. Number 4, look at the last sign. It's a positive. It says our signs will be alike. We have to look back to see what they'll be. They will both be positive. Fifth one, look at the last sign. The last sign is negative. You're going to have one of each. You don't have to look back. You need a negative and a positive to multiply to get a negative. Number 6, the last sign is negative. You're going to have one of each. You don't have to look back. Number 7, the last sign is negative. You're going to have one of each. You don't have to look back. Number 8, the last sign is positive. Your signs are going to be alike. You don't know what? You have to look back and take the sign of the middle term. So both your signs will be negative. This should help you to get your signs into the trinomial. The most common error in factoring trinomials is sign errors. So if you'll work hard on these sign rules, you should be able to avoid those type of errors. Factoring trinomials. Recall that factoring is the reverse of multiplying. What type of problem gives three terms when multiplied? It is a FOIL problem, or a multiplication of two binomials, which usually gives us three terms. Let's look at multiplying two binomials, x plus 4 times x plus 6. So we would multiply the first terms, x times x gives us x squared. We would multiply on the outside. X times 6 gives us 6x. On the inside, 4 times x gives us 4x. And the last term in each set of parentheses, 4 times 6 gives us 24. And the outside and inside terms combine to give us 10x. So we have a trinomial. Now we're asked to factor this trinomial, and let's see if we can go backwards to get the two binomials that it came from. So we know a trinomial comes from multiplying two binomials, so we should have two sets of parentheses. For right now, I'm going to give you signs, and these are both plus. Now, our x squared, if we look back, comes from multiplying the first two terms. So that's where we should break the x squared down into the first two spots. So x and x. You don't want to do x squared times 1. It would give you extra x squared terms. And we have two places left. Let's look at the 24 first. Notice the 24 just takes one step. It takes two steps to get to the 10. The 24 comes from multiplying the last two positions. Now, 6 times 4 is not the only thing to give 24, so we actually need to look at the list of all the possibilities to multiply to give 24. So we could try 1 times 24, 2 times 12, 3 times 8, or 4 times 6. Any of these would multiply to give 24. We have one more term to worry about, the 10x. The 10x comes from combining from the outside and inside terms, the 6x plus the 4x. So from our list, we want them to combine to give a 10. We have like signs, so they're going to add. You have to be a little careful here. If you had different signs, you could use 12 and 2 to get 10. But we have like signs, so we're going to need the 4 plus 6 would give us 10. So we can put those in. And we should always do a check. You don't have to do the entire FOIL. I would just do the outside and the inside. So we're multiplying on the outside, 6x, on the inside, 4x, should combine to give our middle term, and it does. It's not necessary to do an entire FOIL because you're very careful about your first terms. You only choose things that give x squared. We're also very careful about the last term, only picking things that multiply to give 24. So it's the middle term that you have to be careful about because you're doing two steps. So I would check with just the outside and inside. Let's summarize the steps for factoring a trinomial. First, make two sets of parentheses. Second, put in the correct signs. Third, break the first term down into the first two positions. Fourth, make a list of numbers that multiply to give the last term. You want to be systematic. If you skip around, you are likely to leave out the correct choice. Fifth, from the list in step 4, choose the numbers that multiply to give the middle term of the trinomial. And sixth, check by looking at two steps of the FOIL process. The outside and inside terms should combine to give the correct middle term. Let's use these rules to help us factor this trinomial, x squared plus 8x plus 12. So first we'll do two sets of parentheses. And for right now, your signs are still plus. We want to break down the x squared into the first two positions. Then we want to find things that multiply to give 12. We want to be systematic and make our list. So we could try 1 times 12, 2 times 6, or 3 times 4. It is not necessary to do both orders. 4 times 3 would give you the same as 3 times 4. And then we're going to look from this list and see how to combine to get an 8. We look at the first one, 1 plus 12 gives us 13. That doesn't work. 2 plus 6 would give us 8. That one is going to work. Let's make sure the other one does not. 3 plus 4 is 7. So we want the 2 plus 6. Put them in, and we'll just check on the outside and the inside. Outside gives us 6x. Inside plus 2x. And these combine to give us the 8x. So we have the correct choice. Notice if you switch the parentheses and you have the x plus 6 first and then the x plus 2, you're going to get the same. You're going to get 2x plus 6x equals 8x. This is because of the associative property of multiplication. So you always can switch the entire set of parentheses and get the same answer. Let's look at the sign rules for factoring trinomials. First, you should always look at the last sign. If the last sign is positive, what kind of numbers could have multiplied to give you a positive? They could both be positive, or they could both be negative. So to multiply to get a positive, we have to have like signs. Now, we don't know which they are, so we have to look back then and take the sign of the middle term. So for this problem, we look at the last sign. It's a positive, so it says our signs are going to be alike, either plus plus or minus minus. We have to look back to the sign of the middle term to decide. For this situation, we're going to have both positive signs. Let's look at this trinomial. We would first go to the last sign, and it is positive. So it says our signs are going to be alike, either two positives or two negatives. We don't know which, so we have to go back and we will take the sign of the middle term. So we're going to have two negative signs in this setup. Let's look at this trinomial. This time our last sign of the trinomial is a negative. What kind of numbers multiply to give a negative? You have to have one of each. You're going to need a positive and a negative. The order doesn't matter until you put the numbers in. So it could be negative, positive. But to get a negative when you multiply, you must have one of each. So we can put these signs in. We don't have to look back to the middle term. For this trinomial, we will look at the last sign. Since the last sign is negative, we know that we will have one of each, a plus and a minus, and we can just put them in. The order doesn't matter until we fill in the numbers. We don't have to look back. Let's practice finding the signs for these trinomials. So first we will look at the last sign. On this one, our last sign is negative. That says our signs are going to be different. We need one of each. We don't have to look back. Problem 2, our last sign is negative. Our signs are going to be different. One of each. We don't have to look back. Third problem, our last sign is positive. That says our signs are going to be alike, either two positives or two negatives. We have to look back at the sign of the middle term to see what they'll be. So this one will have two positive signs. Number 4, look at the last sign. It's a positive. It says our signs will be alike. We have to look back to see what they'll be. They will both be positive. Fifth one, look at the last sign. The last sign is negative. You're going to have one of each. You don't have to look back. You need a negative and a positive to multiply to get a negative. Number 6, the last sign is negative. You're going to have one of each. You don't have to look back. Number 7, the last sign is negative. You're going to have one of each. You don't have to look back. Number 8, the last sign is positive. Your signs are going to be alike. You don't know what? You have to look back and take the sign of the middle term. So both your signs will be negative. This should help you to get your signs into the trinomial. The most common error in factoring trinomials is sign errors. So if you'll work hard on these sign rules, you should be able to avoid those type of errors. Now let's try to factor some more examples, including the signs. So we have this trinomial. We should first do our parentheses. And then we'll do our signs. So we look at the last sign. It's a positive. It says our signs are going to be alike. We look back, and they will both be negative. You can put those in. We're going to split the x's into the first two spots. And then we want the list of things that multiply to give 3. Well, 3 is a nice number because it's a prime. There's only one set of numbers that multiplies to give 3, and that's 1 times 3. And that does combine to give 4, so it's going to work. We'll put it in. Our check, outside and inside, minus 3x minus 1x does combine to give a minus 4x. Here's another example. X squared minus 2x minus 15. We'll start with our parentheses. And then we'll do our signs. So we look at the last sign. This time it's negative, so we're going to have different signs, one of each. And we'll split the x's. We're multiplying to give 15, so we could try 1 times 15. 2 doesn't work. 3 times 5. And that's actually the entire list. This time the combination is going to subtract because the signs are different, just like your integer rules. So we're going to use the 5 and 3 to subtract to give 2. Now we have to be a little careful when we put the numbers in. We want to get a negative 2. So we need this sign to go with the bigger number. So we're going to need a negative 5 and a positive 3. And let's check. On the outside, minus 5x. Inside, plus 3x equals a negative 2x. And that works. If you get the wrong sign here but the right number, you should just switch the signs. But if you're careful up here, you can avoid that. As you become more experienced with the trinomials, often you'll be able to pick the right combination. It will just pop into your head. And if it does, that's fine. You don't have to make your list. But if it doesn't, you always should do a list so that you're making progress. Here's a good example of when I think you probably would need a list. So let's go ahead with our parentheses. And for our signs, negative at the end, so we're going to need different signs. We'll split the x's. And then we're looking at 60. Nothing pops in my head really fast to combine to give us 7. So I'm going to just go ahead and make my list so that I'm making progress. And I want to be very systematic. Don't skip around, because if you do, you'll jump right over the right one. So I'm just going to divide things into 60. 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. After that, it will flip over. Your next one that you find is 10 times 6. So we can stop there. If you want to know where you can stop on a hard number, do the square root. That's where it will flip over. And so out of our list, we would like to subtract, because they're different signs, to get a 7. So we could use the 12 and 5. That would subtract to give us 7. And let's check for our signs. We want to get a positive 7. So we need the positive to go with the 12 and the negative to go with the 5. And we'll check. Outside, minus 5x, inside, plus 12x equals 7x, and we're good. Let's look at this example. So first we would do our parentheses, and then we would do our signs. Ends in positive, so we're going to have like signs. We have to look back to see what they are. They'll both be minus. We're going to split the x's. And we want things that multiply to give 5. Well, 5 is a prime number, so there's only one choice, 1 times 5. Am I ever going to be able to get that to add to 7? No, it doesn't work, and it is the only choice. Once you've eliminated all the choices and nothing works, then you can say that it is prime. It is not going to factor. So prime would be the answer. Here's a trinomial with a little variation. It has 2 variables. We can still factor it with the same technique. We'll go ahead with our parentheses. And then we would do our signs. So we look at the last sign. It's positive. It says our signs will be alike. And we look back to see that they will both be negative. We can split the x squared into the first 2 spots. To get a y squared at the end, we are going to need a y in each of the last positions. And then we'll work on the numbers. So for 6, we could do 1 times 6 or 2 times 3. And from that list, we want to add, because we have like signs, to get a 5. You have to be real careful here. If it was different signs, you could use the 6 and 1. Like signs, you're going to need to use the 2 and 3 to get a 5. So let's put those in. And we might do a whole FOIL to check on this, just to make sure with the extra variable and make sure we get the xy. So we'll just do a bigger check. So for our first terms, x times x gives us x squared. On the outside, minus 3xy. On the inside, minus 2xy. And last would be plus 6y squared. And the outside and inside combine to give a negative 5xy. And we did get back to the original. What's wrong on this problem? Why does it look different from the others? The trouble is it has the x squared term in the middle. You would never be able to factor it in this order. So just change it. Switch it over to descending order. So you're allowed to rewrite it. Just keep the right signs with the right pieces. So we have x squared minus 13x minus 30. And now it looks normal. So we'll go ahead with our 2 sets of parentheses. We'll do our signs. Look at the last sign. It's negative, so that means we're going to have 1 of each. We will split the x squared into x and x, and we're looking at 30. So we have 1 times 30, 2 times 15, 3 times 10, 4 doesn't work, 5 times 6. After that, the list will flip over, and from this list, we want to subtract with different signs to get a 13. You have to be careful here. Like signs you could add with the 3 and 10, but different signs we're going to subtract. So the 15 and 2 And we want the negative to go with the larger one because that's the sign of the 13. So it will go with the 15 and the positive with the 2. And we'll check on the outside, minus 15x, inside plus 2x, different sign, subtract, and that works. Let's look at one more example. What's different on this trinomial? Yes, it is the 4 in the front. And because I know what comes next, I can tell you that you're very sad to see that 4 in the front, and you would like to get rid of it if there's any way possible. If you think of something that we learned before, factoring by taking out a GCF, if the 4 is in all the terms, then we can take it out, and that would make a nicer problem. So we check, does 4 divide evenly into each one? And it does. So we'll use a different technique of factoring first. We'll take out the GCF. And so the 4 is the common factor. It will go on the outside, one big set of parentheses. And then we'll see what's missing. So 4, to get back here, we're missing the x squared. For the second term, we need a minus 8x. And for the third term, just divide. 4 into 60 will go 15 times. Now, we have to check and see if this trinomial will do more. Anytime we have something to the second power or higher, we have to see if it will factor. The 4 is finished. You're just going to bring it down. And now we're just working on this trinomial. So we'll do 2 sets of parentheses. We'll do our signs. Plus at the end says like signs. We'll look back. Both minus. We'll split the x's. And we're multiplying to get a 15 and combining to get an 8. 5 and 3 probably pops in your head. If it doesn't, make your list. 1 times 15, 2 doesn't work. 3 times 5. And that's the whole list. So like signs add to give an 8. That would be the 3 and 5. And we'll check just back to that trinomial. So outside, minus 5x. Inside, minus 3x. Gives minus 8x. And it works. So our final answer for this problem is this entire piece. You do need the 4 in it. One thing that's really important when you factor these multi-step problems, you need to write this middle line. If you don't write it and you try to just jump to the third line and put the 4 outside and the 2 sets of parentheses, the trouble is you're still thinking about the 60, which you don't really have anymore. You have 15. So be sure to write this middle line because that gives your new problem that you're working on. Factoring trinomials using trial and error. Let's look at this trinomial. The first thing you should always try in a trinomial is see if there is a GCF. Unfortunately, in this one there is not a GCF, and this one is a little harder than the ones in our other lesson because it has a coefficient of the square term that is not a 1. But we'll go ahead and try to work with it. Since it is a trinomial, we know it comes from a FOIL problem. So we can do our 2 sets of parentheses to get the binomials. Also, we can put in our signs. Our sign rules are just like for the other trinomials. We look at the last sign. If it's positive, it says our signs are alike and sends us back to take the sign of the middle term. So we're going to have both positive in this one. Now, we're going to have to worry about a 3 this time instead of just the x squared. But 3 is not such a bad number because there's only one way. It's a prime number. So we'll try a 3 and 1. We'll go ahead and put those in. So a 3, and we'll still split the x's. Now we have 2 places left, and we're looking at the 2. We can either try 2 and 1, or we might have to switch the order. The reason for both orders is that whichever number goes in this last spot will multiply by a 3 instead of by a 1, which is what we did in the easier trinomials. So we have to just put them in and check. The other thing that is messed up with these trinomials is you can't look through the list and just see how to get a 7, because one of the numbers will multiply by the 3 instead of just by a 1. So you actually will have to test them to see what works. By testing, I mean check and do outside and inside. So 2 pieces of the foil. On the outside, we have 3x. Inside, 2x. Combine, and that gives us 5x. We were trying to get a 7x, so this one does not work. So we have to try the other choice. You cannot assume that the other choice would work. So we'll keep the signs, keep the 3x and the x, and we're going to switch and try 1 and 2. Now we'll check outside and inside. On the outside, 6x, inside, plus 1x gives us 7x. That works, so this one is the correct choice. Let's look at another example. So we have a trinomial. There is no GCF. So we'll go ahead with our parentheses. And we'll do our signs. So go to your last sign. Plus says our signs are like. And we'll look back. So this time we need both minus. And we're working on a 3. So our choices are 3 and 1. And we'll split the x's. On the other end, we will try 2 and 1 or 1 and 2. And we just start trying things. So if we try the 2 and 1, and then we're going to check on the outside and the inside. Outside, minus 3x. Inside, minus 2x. Combine, like signs, gives minus 5x. This one works, so we don't have to look at the other choice. When you find the right one, you get to stop. Let's look at another example. So we check the trinomial for a GCF. There's not one, so we'll go ahead and do our sets of parentheses. And we'll do our signs. Last sign is negative. That says we're going to have different signs. Again, we're working on a 3 for our first term, so we'll try the 3 and 1 and split the x's. And at the end, we're working on a 2, so we'll try 2 and 1 or 1 and 2. And we just try something, so we'll try the 2 and 1. We'll check on the outside, minus 3x, inside, plus 2x, gives a negative 1x. This one is totally the wrong number. We're trying to get a 5, so we'll go to the next choice. So we'll keep our first terms and we'll keep our signs, and we'll switch to 1 and 2. And we're going to check outside and inside. Outside, minus 6x. Inside, plus 1x gives a negative 5x. This one almost works. We're getting the 5, but we have the wrong sign. Notice we want to get back a positive 5x. Once you're at this point, all you have to do to make it work is switch your signs. The one that you had as plus should be minus, and the one that you had as minus should be plus, and then it will work. So let's try it. Now we want this one to be minus and this one plus. We keep everything else the same. And we'll do our check. On the outside, 6x, inside, minus 1x. Now we're getting the positive 5x, and that works. Let's look at one more example using something different than the 3 at the beginning. So we look at our trinomial. There is no GCF. That should always be your first thought process. We'll go ahead and do our parentheses. And we'll do our signs. The last sign is plus. It says your signs are alike. Look back. So our signs are both going to be positive. We're working on a 6, so we can try 6 and 1 or 3 and 2. We don't have to do both orders on both sides. So I only do both orders on the right-hand side. If you do both orders on both sides, all it does is move the parentheses around. So it's only necessary to do it on one side. On the other side, we will try 5 and 1 or 1 and 5. So first we'll try the 6 and 1, and we'll still split the x's. We'll try it with 5 and 1, and we check. Outside, 6x, inside plus 5x gives 11x. We're trying to get to 17, so this does not work. We'll go to the next choice. You want to use up the 6 and 1. Go back to it to finish your entire list. The most important thing is to learn to be very systematic. You don't want to skip around. So we're going to try 1 and 5, and we'll check. On the outside, getting a 30x. This one looks too big. Plus 1x, 31x. We're trying to get 17, so this does not work. Now we've used up the 6 and 1. We're ready to try the 3 and 2. So we'll do our parentheses. We'll do our signs just like before. 3x, 2x. And we'll start with the 5 and 1 so that we're very orderly. Check. On the outside, 3x. Inside, plus 10x. 13x does not work. We have to try the other choice. We can't assume that it works. So we still have the 3 and 2. Like signs, and we're trying 1 and 5. Check. 15x on the outside plus 2x equals 17x. This is what we wanted, so this one is the correct answer. Some of the problems do take a long time. Some of them you find quicker. Just remember to be very systematic. That's the most important thought process that you learn from this type of factoring. We have one shortcut that helps in trial and error factoring. It is based on the idea that you have already looked at the trinomial and have not found a GCF. If there is no GCF in the original problem, then there cannot be any common factor in either set of the parentheses. So, for example, if we have 2x plus 2 as one of our factors, the 2 is a GCF, and it would need to come to the outside, but then it would have been a GCF in the original problem. So a common factor in either set of parentheses means that it would have been a factor of the entire problem. So that choice will not work. It is easy to recognize that this shortcut is going to occur if you have problems that begin and end in even digits. But it can also be any others that have common factors in the first and last term of the trinomial. Let's look at a problem where we might be able to use this shortcut. So we're going to factor this trinomial, 2t squared minus t minus 10. There is no GCF in the entire problem. But if you notice, the first term, the 2t squared, and the last term, the minus 10, have a common factor of 2. So we're going to get some common factors in some of the parentheses, and those choices can be thrown out. So let's go ahead and set up our parentheses, and we're going to want different signs. For our first term, we're going to have to use 2 and 1. So we can go ahead and put that in and split the t's. For the 10, we can try 1 and 10, 2 and 5, and we can turn them over. Switch the order. So we have 4 possibilities altogether. Now, anything that would give us a common factor in this first set of parentheses, we can throw away. We're not going to get one in the second set because it's a 1t. We don't care about a common factor of 1. So the choices we can throw out, a 2 and 5 we can throw out because it would put a 2 in with the 2t plus. So let's look there and just see. It would give us a common factor in that set of parentheses. So it's not going to work. We don't have to check it. We can throw it away. There's one other choice that we can throw out, and it also comes in the first position. Notice the numbers in the first position go in the first set of parentheses. Second position, second set of parentheses. So if we're looking for the first set of parentheses, the 10 in with the 2, it's not going to work. It will put a common factor in the same set of parentheses. So the 2 and 10 have a common factor. It's not going to work. We can throw it away. We don't have to even try it. So we only have 2 choices to try instead of 4. From the ones that are left, I would tend to choose the numbers that are closer together first, just because that's usually how they write textbooks. So I would try the 5 and 2. And you still need to check outside and inside. So minus 4t plus 5t. I am getting a 1t, but my signs are wrong. I want minus and I have plus. So all I have to do at this point is switch the signs. The one that is plus should be minus, and the one that's minus should be plus, and it should work. Let's just double check. On the outside, 4t minus 5t gives us a negative 1t, and that's what we want. So our shortcut eliminated half of our work. Let's look at this trinomial, 4y squared minus 11y plus 6, and see about a shortcut. It should have a shortcut in it because the first term, 4y squared, and the last term, 6, have a common factor of 2. So we'll start with our parentheses, and we can go ahead and do signs. This says do like signs, both minus. And then we'll list our choices. For the first term, we can try 4 and 1, or we can try 2 and 2. For the 6, we can try 1 times 6, 2 times 3, 3 times 2, or 6 times 1. So now all of a sudden we have 8 choices. So that's starting to look like a lot of work. We'd like to get rid of some of them. Now, since the first term and the last term are both even, they have factors of 2, I'm betting that this 2 and 2 is not going to work with anything because it has an even digit in both places. So it's going to have even number in both sets of parentheses. Let's just look at it. But my guess is it's not going to work with anything. For the first choice, the 1 and 6, that would put a 6 in the second parentheses with the 2. So it's not going to work. The second choice would put a 2 in with the 2y. So it's not going to work. The third choice would put a 2 in the second set of parentheses with the 2y. So it's not going to work. And the fourth choice would put a 6 in with the first 2y. So it's not going to work. So if I have an even digit in both spots, and that's what I have originally in the first and last, that's not going to work. So you don't have to even try it. I did it here just to show you for the shortcut. So we're going to need to go with the 4 and 1. And we'll make an extra column to see what to throw away. Now, it's the first set of parentheses, so your first position where you're going to get common factors. We're going to get a common factor with the 2 and 3. So if we put that in, common factor between 4 and 2. So that's not going to work. Think for a second. There's one other one we can throw away. Anything that would give a common factor in that first set of parentheses. And it is going to be the 6 and 1. 6 in with the 4, common factor of 2. So it's not going to work. We'll throw that away. As you get more experienced, you won't need to write all these. You'll be able to just look at the position, maybe write it once, and then you can see what to throw away. So for the 2 that are left, so really out of 8 things, we would only have to try 2 things. That's a lot better. From the ones that are left, I would try the 3 and 2 first. And we check. On the outside, minus 8y. Inside, minus 3y gives a negative 11y. And that works. So that would be my choice. So I really would have only had to try one thing. We'll look at one more example for our shortcut. Notice your first and last terms. They're both even. They have a common factor of 2. So we know we're going to get some things we can throw away. First, we'll list the choices for 20. We could do 20 and 1. We could do 10 and 2. We can do 5 and 4. On the other side for 8, we can do 1 and 8, 2 and 4, 4 and 2, or 8 and 1. So now if we had no shortcut, we would have 12 possibilities. So we really want to try a shortcut. Right, we're going to have different signs from our last sign. Now, with both of those even, I'm betting up front that 10 and 2 is not going to work with anything. We'll put it down just to see, but after you get used to these, you wouldn't have to try it. Let's see what happens. For the 1 and 8, it will put the 8 in with the 2, so it's not going to work. You can throw it away. For the next set, 2 and 4, both parentheses would be messed up. 2 in with 10, 4 in with 2. So you can throw it away. You don't have to do it. The third one, 4 in with 10, 2 in with 2. Both parentheses are messed up. It's not going to work. And the fourth one, 8 in with 10, common factor of 2, throw it away. So none of those work with the 10 and 2. We can cross it out. From the ones that are left, I would go to the 5 and 4. 5 is a prime, so if the factor is not a multiple of it, we're not going to get a common factor. In the second set of parentheses with the 4, we have more of a chance of getting some common factors. First, we could look at the 1 and 8, but 8 would go in with the 4. Common factor, it would not work. 4 would go in with 4. That one's out. Third one, 2 would go in the parentheses with the 4. That one's out. The fourth one, the 8 is going to go in the parentheses with the 5. That's okay. And 1 in with 4 is okay. So that one we have to try. And we'll check outside minus 5r, inside plus 32r, and those are different signs. And this actually works, so I wouldn't have to try anything else. From all the things I listed, the first thing I actually did try worked. So this would be my choice. But you can see how much help it is to look at what things can get thrown out. We'll go ahead and look at just the 20 and 1 just to help you get this shortcut down pat. But you would not do that when you're normally working the problem. Once you find the answer, you're done. So let's see about the 20 and 1, what would happen and what we would have to try. So this time it's going to be the first set of parentheses where you get the shortcut. 1r is not going to have a common factor over there. You don't care about a common factor of 1. So 20, when we look at these, the 1 and 8 would be okay to try. 2 and 4 would not. 2 would go in with the 20. It's a common factor. 4 would go in with the 20. Common factor. 8 would go in with the 20. Common factor. So out of 12 things, there really were only 2 things to try at all. So I hope you can use this shortcut. Good luck. We're going to look at an alternate technique for factoring trinomials with a leading coefficient that is not 1. So our A is some other number. So these are not the very nice problems. We will still first look for a GCF. Second, see if it's a perfect square trinomial or a good candidate. And then we will go to a method called grouping. What we will do is we're going to keep the first term, keep the last term, and we will split the middle term into 2 terms, which will give us 4 terms, and with 4 terms, we use grouping. We'll do the same problems that we did in the trial and error module so that you can see the difference in the 2 techniques. All right, so we're going to factor this trinomial. First, we're going to keep the first and last term, so we're going to keep the 3x squared. We're going to keep the plus 2. And we're going to split the 7x into 2 terms. Now, we have to see how to split that. And to find the numbers that do that, we're going to multiply our a, so the coefficient of the x squared term, times our c, which is our constant. So a times c, so 3 times 2 is 6. So we're going to find numbers that multiply to give 6, and they're going to combine to give the middle term. They're going to combine to give the 7. And like our sign rules before, if we look at the sign of the last term, if this is plus, then they're going to add. So they're going to be like signs, the ones that go in here, they'll both be plus. So they're going to multiply to give 6, and they're going to add to give 7. So factors of 6, 6 and 1, or 3 and 2. To add to give 7, it will be the 6 and 1. So we're going to split the 7x into 6x plus 1x. And we'll put them so that they should group. So we will put the 6x here and the plus 1x. It's important to check here. These two should always give you back that middle term. So 6x plus 1x is 7x. Now, you have just changed your problem. You have 4 terms. Factor it by grouping. So in grouping, make 2 groups, and then in each group you look for a GCF. So in our first group, we have a common factor of 3x, and that leaves us with x plus 2. In the second group, there's nothing common there. We can go ahead and take out a 1, and the parentheses are going to match. That will leave x plus 2. What you hope with grouping is that you get this common binomial, which we did, so we can take it out. That is now our GCF. And to get back just to the line above, we're missing 3x plus 1. Let's try the same technique on another problem. So we have a trinomial, no GCF, no perfect square. So we'll go ahead and we'll keep the first term. We will keep the last term. And we're going to split the middle term, right? We do end with a plus, so that says we're going to do like signs. This time they'll both be minus. So we're going to find our a times c. 3 times 2 is 6, so numbers that multiply to give 6. And they're going to add to give 5. So 6 and 1 or 3 and 2. This time you're going to need the 3 and 2, and they're both going to get a minus. So we'll do a minus 3x. Each one will get an x. And a minus 2x. Double check. These should combine to give minus 5x. They do. So now we have a problem with 4 terms. We will factor it by grouping. So we'll make 2 groups. And then we'll take out the common factors. So in the first group, we have a common factor of 3x, and that will leave x minus 1. In the second group, because it starts with negative, we'll choose a negative GCF there, a negative 2, and that will leave an x minus 1 because we took the negative out. We did get a common binomial, x minus 1, that's our GCF. To get back to that line, we're missing 3x minus 2. Let's look at another example. So again, a trinomial, no GCF, no perfect square. So we're going to keep the first term, keep the last term. Notice this time it ends in a negative, so we're going to need different signs when we split the middle. So we're going to find a times c equals 3 times 2 will be 6. And because it ends in negative, they're going to subtract. So a minus 6 is going to equal 5. So for 6, we can do 6 and 1 or 3 and 2. To subtract and get 5, we're going to have to use the 6 and 1. And we want a positive 5x, so that sign should go with the larger. So we want plus 6x minus 1x. Right? Those will combine to give 5x, so we're good. And now we have 4 terms. We go with grouping. So for the first group, common factor of 3x leaves x plus 2. In the second group, because it starts with negative, we'll take a negative out. There's no other common factor. We can write a 1 there if we like. And that will leave x plus 2. Our binomials do match, so we'll take that out. That is now the GCF. And to get back to the line above, we're missing the 3x minus 1. One more problem to look at with this technique. So we look at our trinomial. There is no GCF, and we do not have a perfect square trinomial. So if we're going to try grouping, we're going to keep the first term, 6x squared. We're going to keep the last term, plus 5. And we're going to split the middle into 2 terms. We find our numbers, a times c. This time they'll equal 6 times 5 is 30. And this ends in plus, so that says like signs, and they're going to add to give 17. So we have 1 times 30, 2 times 15, 3 times 10, 4 doesn't work, 5 times 6, and to add to get 17, 2 and 15. So we will put each of those with an x, and I'm going to put the 2x with the 6x squared and the plus 15x near the 5. Now we have 4 terms. Double check. These do combine to give this 17, so we're good. And now we have 4 terms. We will factor by grouping. First group, we have a GCF there of 2x. And that leaves 3x plus 1. In the second group, we have a 5. And that leaves 3x plus 1. And we did get a common binomial. So we'll take out the 3x plus 1. It is now our GCF. And to get back to the line above, we're missing 2x plus 5.